Hey! So can everyone hear me all right? Need no microphone or anything, right? It's kind of a small room. Okay, yeah, so what am I going to talk about? Practical HTTP header attacks is the name of this talk. It was thought up kind of spur of the moment because Victor roped me into doing this, and he was like, so you can hold the talk on anything you want. And at the time I was doing some research into HTTP headers and attacks through them. Unfortunately, my research is not ready to present yet. So this will be a rundown of some common HTTP header attacks, how to abuse them, how to protect yourself against them, and kind of taking a look at the state of the nation in terms of header attacks. Please feel free to stop me with any questions you might have during the talk. So, who am I? Johan Rydberg Möller, as you mentioned. Yes, grab your phone, it's fine. I'm a co-founder of a couple of things, and if you want to reach out to me, you can find me on Twitter. It's probably the easiest way. So, I've mentioned this already. Let's start off with maybe the most basic and one of the older HTTP header attacks. Header injection. So, if you have something a script that takes input from the user, in this case in the origin parameter, and allows the user to use unsanitized input, using that then to populate your header, you will end up with a situation where someone can write a new header into the response. This is called HTTP response splitting or header injection. The attacker in this case uses carriage returns and line feeds in order to break up the headers in the response. In this case, this leads to a session fixation attack. Now, this vulnerability could also be used to create, for example, a cross-site scripting attack by splitting the headers using multiple carriage returns and then injecting your own HTML or JavaScript code. In this case specifically, that probably wouldn't happen because we're returning a 302 redirect. So the JavaScript will not actually be interpreted by the browser or executed. But I've seen this happen where you can actually use header injections to create cross-site scripting attacks to then attack the user in a later stage. So, as always, the problem here is that we're not sanitizing user input. We're trusting input that ends up somewhere else and it's not sanitized, and people can abuse that. We've seen this happen before with cross-site scripting and SQL injection. It's the same basic idea. So let's move on to host header attacks. Now, the host header is supplied by the user. It's always included in a HTTP request. When you're browsing the web, you're going to be sending a lot of host headers. Now, host headers are used by web applications to tell the application where it is at the moment. So a lot of applications use this to create links. For example, as you can see, the href link actually even includes a secret token. The link at the top uses this to specify which host the web application currently is at. So if my host header said evil.com, it would be a link to evil.com with a token included by the application. You can see where that could be bad. Developers trust the HTTP host header even though it can be manipulated by the user. This is not something that is controlled by the application. It comes from the user, and you should never trust it or build any links or anything like that upon it. So you can see in the last example, we have a script src. In this case, if this was executed, it would include your evil script from your domain, and you'll have full control of the DOM, JavaScript injection, XSS, basically. Now, you're probably wondering how this can be abused, because you cannot remotely change the value of the host header for your victim. You can't do like a CSRF attack changing the value of the host header. There are a few ways this can actually be achieved. Now people on the stream can hear me. not the stream, the video. Okay, so host-related attacks, yes. One way to abuse this is through cache poisoning. Now, cache poisoning is a way of including a malicious request in the web cache for an application, which means that the web application or the caching service solution will serve up your malicious requests to subsequent users in order to decrease the load on the servers. There are multiple ways of doing this, and it kind of depends on the specific caching solution you have. Varnish is a common one. In Varnish, you can do this by sending multiple host headers, because that will cause a disconnect between what Apache or Nginx sees and what Varnish sees. And it might actually end up saving your evil request instead and serving that up to subsequent users. In this case, leading to maybe cross-site scripting or different ways of stealing user application data, stuff like that. There are other ways to do cache poisoning, but they're kind of dependent on the caching service, as I mentioned. So you would have to try and figure out which one is used. This also applies to application layer caching, depending on how it's done. I know that Joomla has had a problem with this in the past. In fact, Joomla specifically have had a lot of problems with header injections. I think the previous slide, they've used the host variable to write links and stuff into their source multiple times, which led to problems. So yeah, maybe keep your Joomla updated or use something else. Another way you can use the host header to attack your users is by using password reset poisoning. So when a user requests a password reset, what usually happens? Well, you can read on the screen. What usually happens is an email is created and sent to that user containing a link back to the application, which includes a token, which is supposed to be secret, and the user can use that token to create a new password for their account, right? Well, what if the application builds that link based on the host header that the user supplied when requesting the password reset, right? So what's going to happen in that case is that the legitimate user is going to get the password reset email, but the link that he's supposed to click in the email will actually go to evil.com, if that was the host header you specified. So this is a way of phishing your users, but it's even better than that, because you can either spoof the password reset page and try to steal information that way, or you can just log the token that was included and then use that token in a legitimate way on the original web page, allowing you to do account takeover, basically. So what else can we do with headers? SQL injection? You bet. XForwardedFor is a very interesting header. It's considered the de facto standard for identifying the originating IP address of a client connecting to a web server through an HTTP proxy or load balancer. Now, this header can be manipulated by the user. So wherever you have a function such as IP address, you can see in this SQL query here, that might actually be based on the value of the XForwardedFor header, which is supposed to be set by a load balancer or proxy. But if you set it as a user, it will still be accepted. So what if you include, some basic SQL injection into that statement? It's probably not going to be sanitized because it's expected to come from a trusted source, the proxy or the load balancer. But of course, it's not. It comes from evil people, such as yourself. And this happens time and time again. We've also seen it in user agent headers. We've seen it in refer headers. Basically, anywhere that people don't expect data to be manipulated by the user and don't realize that it actually can be a lot of the time, and then include it in a SQL statement somewhere. Now, obviously, this is not a pure HTTP header problem. We've solved SQL injection problems before. You should be using parameterized queries, that kind of stuff. But also, don't trust user input. Coming back to this time and time again, but it's the core problem with IT security, basically. Don't trust your users, guys. They suck. So, there's other weirdness as well. You can spoof your IP address through XForwardedFor, which could give you access to internal systems. I've actually seen this. You don't even necessarily have to spoof an IP address, but let's say you're trying to access, let's try like intranet.example.com, and you'll be kicked out because it's not available from the outside. Well, what if you specify your host header to be localhost? If the application is poorly configured, it could actually trust that is where you're coming from. So it will say, oh, he's coming from localhost. It's fine. Show him our internal stuff. This is really weird, and it really actually happens in the wild. And that's the thing with these kinds of headers, especially the ones that control where you're at in the network. They can pop some really weird behavior in different layers of the application. So you could have a load balancer or a proxy server or logging system somewhere down the line, which is going to use the data from your header in some request somewhere, and weird shit happens. Which is why this is really hard to keep track of and actually identify all the places where stuff like this could go wrong. I'm going to show you a little bit later how we can use a couple of tools to actually find and abuse this kind of functionality. Now, I mentioned logging systems. Log injection is a slightly lesser known vulnerability. It can be used to fill up logs. It can be used to hamper forensic investigations. Basically, if you can inject carriage returns or line feed characters into data that is going to end up in the log, you can just build entire new log entries based on fabricated data. This could be interesting if you're trying to do evil stuff, because all of a sudden you're going to have a bunch of just nonsense in your logs, and you won't be able to tell if the other data that's in there is actually correct. Or you may be able to use that to point to someone else. Like, no, I didn't do that request, that was this guy. This can also be used, of course, if the stuff that's stored in the logs is then later viewed in a separate system. You might end up with stuff like cross-site scripting vulnerabilities and second, third order injections, that kind of stuff. So it's always a good idea to consider your HTTP headers as pure attack vectors, because they are. If you can manipulate them, something somewhere is probably using that data, because if they didn't, what's the point of having the header, right? So don't forget about that. Now, load balancers, reverse proxies, flip out over unexpected data. This happens, and it's really strange. It can be really hard to pinpoint exactly what is going wrong, because it depends on how multiple systems interact with each other. So you might have an Nginx server or an Apache server with some weird mod proxy rule that then interacts with a load balancer down the line, and just given that specific set of circumstances, that can actually create some really interesting vulnerabilities if it trusts data that's coming from, for example, the XForwardedFor header or host header, XForwarded host header. A lot of these headers that not a lot of people think about. So that's why you need to do this kind of testing, because it's not always obvious when coding to see like, all right, I know I'm not trusting these headers, but some weird rule somewhere in a proxy or something in your infrastructure might actually do that. So you might want to do some real kind of black box testing of this stuff to see if anything pops. NTLM hashes. I'm not going to mention the specific company, but it's a big one in Sweden. And basically, if you go in and change your host header or XForwardedFor header to point to localhost, it's going to flip out and start giving you back internal NTLM hashes. Look, this is just to illustrate the weirdness involved with this kind of research. I have no idea why that happens. I've just seen while scanning the web with these kind of vulnerabilities that, all of a sudden NTLM hashes from internal systems get sent to my machine. Don't know why. It's definitely not something someone intended to be that way, but you know. So let's talk a little bit about tools. Now, Burp Collaborator is a fantastic feature of Burp. I don't know how many of you guys have actually used it. Like 3 people. Okay, definitely look into using Burp Collaborator if you haven't. It's amazing. Now, how many people in here have used Burp before? Almost all of you. Okay, if you have the paid version, you have Burp Collaborator installed. So please do try it out. It's a fantastic tool because what it does is sets up a listening server with a unique ID, which responds to and records pingbacks from remote servers. So, for example, when you start up Burp Collaborator, you get a specific link. So it's like yoursecretid.burpcollaborator.net or whatever. You can use that link and put it into your attack suite, your fuzzing databases, your spidering tools. You can put it into headers you're sending to the application you're trying to attack. And if the application at any point sees that link and does a pingback to that server, the Burp Collaborator is there to record and respond appropriately. And you will be able to see like, oh shit, I sent in this in the host header, and 3 steps down the line in the internal infrastructure, some system reached back out to that server and tried to start a DNS conversation, or tried to ping it, or tried to establish a HTTP session. So this is really useful for finding second, third order injection attacks and stuff like that. And as I said, it has support for a bunch of different methods of talking over the internet. So it can complete HTTPS sessions, handshakes, SMTP conversations. So you can inject it into mail conversations, which is really interesting. DNS, etc. If you haven't used it, I highly recommend it. Now, Burp Collaborator everywhere is taking Burp Collaborator and making it just way more awesome. This is based on some research done by James Kettle at Portsphere. And basically what he did was he built a plugin to Burp which uses Collaborator, but it sets up a unique session per request. Actually per header injected in this case. Inject several headers containing these payloads automatically on every request that goes through Burp. I'm going to show you a slide. Actually, I can do that right now. So when you use Burp Collaborator, your outgoing requests are going to look something like this. So it adds a number of really weird headers with a unique ID for the Burp Collaborator for every header. So you can see which header at what point from which application actually created the ping back to your Collaborator server. This is a fantastic way of automatically finding these kinds of vulnerabilities. And I bet you if you turn this on and just go browsing the web, you're gonna find a lot of weird shit. Be forewarned though that using this will also cause a lot of web applications to just crash. So that might be something to consider. For example, if you try to access any site behind Cloudflare with Burp Collaborator on, it's just going to say no. No. Yeah, so you might want to beware a little bit. And actually, if you haven't seen James Kettle's talk, I'm going to give a link to it later in this slide deck. When he created this and released it, he didn't include the spoofed part at the beginning of each URL. And unfortunately, that led to the burpcollaborator.net server being blacklisted just everywhere because everyone thought that, oh shit, burpcollaborator.net is attacking the entire internet because everyone who was using Burp basically used Burp Collaborator, and then a lot of malicious traffic going onto the internet. But that has now been taken care of, so it should be fine. And again, Burp Collaborator, if you're scared about a third-party system getting pingbacks from servers you are maybe pen testing, that could be information disclosure. Portswigger has said that they will not record anything. They won't, They will not sell your data. They won't actually be able to look at it. But, they're Americans, I think, aren't they? So yeah, you might want to be careful with that. But if you are scared of that, you can actually set up your own collaborator server. It's as easy as just starting Burp from command line with a couple of arguments, and you can host it on your own infrastructure. So that's pretty cool. This is very useful for finding header-based attacks, but it only includes these headers. You can go in and modify the code yourself, but I'm actually in the process of, together with Alexander, who's here somewhere over there, we are currently building a plugin for Burp, which lets you manually specify the exact headers you want to include automatically in each request and the payloads you want to include. And it will then also magically send a vanilla request without those headers and compare the results. And if there's any difference, it will register this as a finding in your Burp session. So that's also pretty useful for finding these kind of vulns. It's not really ready for prime time yet, but it should be soon. And when it is, we will release it open source for everyone to use and have fun with. If you want to do this online, if you want to do it at scale, you might not want to use Burp because it's built in Java and it only has so many threads, and shit can get weird. So you might want to use masscan for that. You can specify that to include the headers you want and still use the Verb Collaborator for pingbacks. Obviously, if you want to test specific things, use curl, just with the specify the headers you want. Also, I want you to check out James Kettle's talk, as I mentioned. It's online, it's on YouTube. It's called Cracking the Lens, Targeting HTTP's Hidden Attack Surface. And I want to mention some takeaways here. I've mentioned this before, but make sure you know where header values are used and how they're used. So always sanitize user input. This should be, basic stuff. But a lot of people don't consider like XForwardedFor, XForwarded host headers. They don't even think about those. They don't even think, why would someone use them? I didn't write the code for anything to include the XForwardedFor header, but you're not necessarily sure that some third-party system you're using doesn't. So make sure to actually do some testing on your own application when it comes to this stuff. If you want lists of headers, I highly recommend Portspear's blog post about this. They have a lot of great examples. Also, if you're building alarms for logging for CM systems, consider looking at more obscure HTTP headers. If someone is supplying data in a header that you know that you won't ever use, that's probably something that's malicious. You might want to look into it. So that's just an easy canary to put into your logging systems. Further research, there are a lot of headers. I've mentioned just a few. There are also a lot of weird proprietary headers used by just some applications. This is often undocumented functionality, and undocumented functionality usually means bugs and security problems. So make sure you try and keep an eye on those first few lines of your HTTP requests whenever you're doing pen testing, because very occasionally weird shit will turn up there, and it's interesting to go and have a look at. Anyone interested in bug bounties should definitely be looking into this. When James Kettle wrote Verb Collaborator, he used it to test it. He basically went on to HackerOne and BugCrowd and compiled a database of all their open bug bounty programs that included this kind of stuff in their scope. And then he fired off payloads using Verb Collaborator against these systems. And I think he made $30,000 in about 10 minutes in bounties. So that's definitely worth looking into if you're interested in that kind of stuff. Highly recommend his talk and anything you can find on Portspear's site. There's a bunch more research currently being done. When we get further in ours, I hope I can come back here and show you a little bit more. For now, I'm just going to tell you there's a lot of weird shit going on. When I have something more concrete to show you, I'll be happy to do so. This is kind of a shorter talk, but we're still clocking in at around 25 minutes. So if we can do 5 minutes of questions, if you have any, that would be fine. If you don't have any, that's it for now. All right, thanks. Any questions?
Open source alternatives for Burp?
You could always use Owasp. SAP. That's a good alternative. It gives you the proxying capabilities of Burp, along with some scanning functionality. It doesn't have the Verb Collaborator tool. Obviously, Burp has a free version. You can use that. I don't think Collaborator is included in the free version. But when we release our plugin, that's going to be somewhat similar, and that's going to be available in the free version of Burp. Obviously, you could script your own basically similar functionality, or use masscan or curl, as I mentioned. If you want to build up similar functionality to the Burp Collaborator, that could probably be done. You might not want to build the entire functionality of completing entire HTTPS handshakes or SMTP conversations, that kind of stuff. But definitely setting up just a listening server to notice if something pings back, that should be easy. Yeah. Anyone else? All right, cool. You can always grab me afterwards if you want to hear about more weird header stuff. Thanks.